Okay, so our learning goal today is I can choose a method for factoring. So in other words, you're going to have to do some critical thinking first of all. You're going to have to do some analyzing. And then you're going to apply one of or more than one of the many methods you've learned for factoring so that the polynomial is factored completely. Like I just had you do with the x to the 8th power minus y to the 8th power. This is factored completely. In other words, you don't stop until none of the factors can also be factored, okay? So, to factor a polynomial completely, since that's our goal today, we now know all these factoring methods. So to be able to factor a polynomial completely, you will need to check resulting polynomial factors to see if more can be done. So you don't get to just do one factoring, stop and say I'm done. You have to check each of those factors and see if there's anything more you can do. So here's the things that, first and foremost, number one, always, always, always look for a GCF. See if you can GCF it first. Just make that your first step. Not every polynomial has a GCF. You are not going to be able to use the GCF method for every polynomial, but you are going to check it out to see if you can, okay? And then, if you are working with a polynomial that has 4 terms, we are going to look to see if you can factor it by grouping. That's the method for the 4-term polynomials. So you'll try to factor it by grouping. That's the diamond method. No, that's not the diamond method, excuse me. That's the making 2 groups. Each of them has their own GCF. And then we bring them back together, and the GCF that those 2 groups had in common times the other factor. The binomials, we're going to look for a perfect square trinomial. Oh, no, what am I doing? I thought that sounded wrong. Binomials aren't trinomials, they can't be both. We're going to look for difference of squares. Sorry about that. We're going to look to see, is this a binomial that is the difference of squares? And if it is the difference of squares, of course, then we'll factor it. And the trinomials, we're going to try our diamond method. So we had trinomials that were factorable that were not perfect square trinomials. But we also have the perfect square trinomial. So we know a shortcut for the perfect square trinomials now. Doesn't mean we have to use it. We can still use the diamond method. But we also have to remember that there are other trinomials now. Just because the last ones we've been working on are perfect square ones does not mean that we still don't know how to factor other trinomials. Okay, so we have all of these different things that we have learned that now we have to apply. So, number 1, what are we going to look for first again? What's our first step? What are we going to look for? A GCF. Okay, so look at that binomial. Does it have a GCF?
Yes.
Okay, go ahead. What is it? 3x. Now, remember what I talked about, how it's always nice to have the first term of a factor be positive? So instead of factoring out a 3, let's factor out a negative 3. So let's do a negative 3x instead of a positive 3x. Because it's nice to have a positive first term in our binomial factor that we're going to have. So what's negative 3x cubed divided by negative 3x? X squared. Plus negative 9. Now, if we would have factored out a positive 3x, then we would have had a negative x squared plus a positive 9, so a negative x squared plus 9. But then, in reality, because one of them is negative and the other one's positive, we would have had them trade places. We would have said, we really have 9 minus x squared. so that we would understand that we really could still keep factoring. This is just gonna come down. We're not gonna forget about it. Now we're gonna look at this and say, can it be, I'm gonna change it to, get rid of that sign, that double sign. It's a binomial. When it's a binomial, we're gonna determine if it's a difference of squares. Is this the difference of squares? So what can this be renamed as? X minus 3, x plus 3. So at this point, maybe we still need to do this. You decide if you do. You don't. Just rename it. Now we look at those two factors. Can either of those be factored? X minus 3 is a binomial. Is it the difference of squares? Is x a square? No, it's 3 squared. Neither of them are. Both of them have to be. How about x plus 3? That's a binomial. Can it be factored? Is it a difference of squares? No. So our final answer is going to be our GCF of negative 3x and our other two factors of x minus 3, x plus 3. This is its factored name. It has been factored completely. Now, are there different ways that could look? Absolutely, but it has to still look correctly. It still has to be able to multiply back to what we started with.
Where did the 3's come from?
Where did the 3's come from? They came from the square root of 9. Right here. Square root of 9 is 3. Any other questions before we try the next one? Okay, what's our first step going to be?
GCF.
GCF. Look to see if there is one.
Yeah.
Sometimes there is, sometimes there isn't. Okay, what's the GCF then? 5y, okay. What's the resulting factor then?
Minus 4y.
Okay. Okay, this is a trinomial factor now that we have to determine, can it be factored now? What do you think? Can y squared minus 4y plus 4 be factored? Okay. Do we need to use the diamond method, or should we first check to see if it's a perfect square? Yeah, let's see if it's a perfect square trinomial. Because it passes this test right here. It has the addition right here, doesn't it? As long as it has the addition there, it's already passed the first test for being a perfect square trinomial. The next test is this a perfect square? Is y squared a perfect square? Is 4 a perfect square? Okay, so when we take the square root of y squared, and we take the square root of 4, and we double the product of those guys, we get 4y. We need a negative 4y. Well, remember what we said? The square root of 4 has two square roots. It has a positive and a negative. So that could be a negative 2 at the end there. So this is a perfect square trinomial, isn't it? So now we really, okay, remember this just keeps, this comes down. Don't just get in the habit of drawing those arrows, because otherwise you know what happens with that GCF, if there is one, it gets forgotten. We can now just set up the binomial factors for this, because we have discovered it's a perfect square trinomial. So what will each binomial start with? Y. What will each binomial end with? 2. What operations? Subtraction in both. Nope, subtraction in both. When it's a trinomial, the binomial factors match exactly. And what decides whether it's addition or whether it's subtraction? Yeah, the negative 4y, the middle term, is the one in control of that. Okay, now we have two binomial factors that we gotta look and see if we can factor those. So, this is a binomial with subtraction. Is it a difference of squares? No. So we are ready to say the final answer for this one is, and we can write this as a shortcut, y minus 2 squared. Take it times, it's being taken times itself. So this is our final answer for that. I'm going to tell you right now, in the homework up there, it says only 2 are not factorable at all. In other words, nothing you try will work, so you say not factorable, but there's only 2 of them. And the other thing I'm going to tell you right now is none of these in those evens problems, we have 2 groups of evens problems to do, none of those will have less than 3 factors in their final name. Less than 3. It'll be 3 or more. So if you only get 2 factors, you're not done. And I won't count your papers complete tomorrow. I'll say you didn't give it enough effort. Okay, let's look at this next one. GCF? No. So let's put that in our notes. That, you know what, we did look for one, but there wasn't one. It's a trinomial. Any possibility of it being a perfect square trinomial? Well, it meets this test. It has the plus at the end, right? It meets that test. Is this a perfect square? 2 is a perfect square? Really? Since when? I thought it was 1, 4, 9. I don't think 2 is a perfect square. So we are going to do the ABC method. We have a 2 for an A, an 11 for a B, and a 6 for a C. Oh, now we also have to think, wait a minute, A is not 1, so I know I have to work harder at this one. The A equals 1 are the nice ones. This one I have to work a bit harder at. But let's start with what we do have to do here. We're going to take 2 times 6 and put 11 down here. What is 2 times 6? 12. So we need 2 numbers that multiply to be 12, add up to 11. 2 numbers that multiply to be 12, add up to 11. Well, what are all possibilities? 1 and 12? That work? No, that adds up to 13. 2 and 6, what does that add to? 8. 3 goes into 12. 3 and 4? 7. Is there anything else that goes in? Are there any other factors of 12? Okay, what do you think? This is not factorable. And this much shows up. This supports our claim that it is not factorable. We could not find anything that multiplied to be 12 and added up to 11. We showed that we can't GCF it. We showed that we tried the diamond method on it. That's our support for it not being factorable. Okay, let's look at the next one. GCF? They're both even numbers. At the beginning, 98 and 50. Wait a minute, you're telling me that method?
2x.
Okay, well, so we could take a 2x out of both of them? Both of them are divisible by 2 for sure. So let's take a 2 out. And then this one has 3 factors of x, and that one has 1. So yeah, I'm thinking 2x is our GCF. Anybody know what 98 divided by 2 is? 49. X cubed divided by x? X squared. So 49x squared. Subtract 50 divided by 2? 25. X divided by x? They're gone, right? So we have 25y squared. So now we have a binomial, and we're going to check to see. Let's bring this down. Let's not forget about it. We have a binomial with subtraction, so we're going to see is the difference of squares. It's 49x squared a perfect square. Yes. How about 25y squared? Okay, so we basically basically then can take the square root of both of those. And again, if you're to the point you don't have to show this off to the side, I'm fine with it. Both binomial factors are going to start with what? 7x. Both binomial factors are going to end with 5y. What operations do we put in these? Addition and subtraction, one of each. Binomials have, we have the difference of squares. Okay, now we look at these. You think either of those are factorable, 7x plus 5y? Okay, now, here's the deal. If we did not get out the biggest number we could, like let's say 2 was the largest, common factor that they had, then it would show up here. So if there's still another number that could be factored out, we would factor that out. So let's just say, by chance, this said 10x plus 5y. We would say, oh, wait a minute, both of those are divisible by 2. You can take 2 into 10, you can take 2 into 5. So we would have to factor out another 2. So if you don't get the greatest common factor in the beginning, you need to catch it later on in the problem. Okay, how about 7x minus 5y? Can that be factored anymore? No. Okay, so our final answer is 2x times 7x plus 5y times 7x minus 5y. This is our final answer. Okay, you start the next one on your own. Start it. Do you agree with me? So this one can be GCF also, right? Okay. Let's make sure that we have the greatest common factor by just looking at all 3 of these and make sure there's nothing left that could have been divided out of all 3 of those. Just catch it early. Make sure you have the greatest common factor right away in the beginning. So nothing else can be divided into each of those terms, right? Other than 1. So this is our GCF that's going to come along down. This is a trinomial. Can it be a perfect square trinomial? What's the first test? It does not even pass. Yeah, it doesn't have addition at the end here. It does not have addition, so we already know it's not a perfect square trinomial. So we're going to do A, B, C. A is 2. B is -1. C is -3. Diamond. You have to take 2 times -3, which is -6. They have to add up to -1. What are those 2 numbers? 2 and -3. Is our A equal to 1? No, equal to 2. So we cannot just say, okay, we are ready to set up our factors. They are A plus 2 and A minus 3. No, that would not multiply back to 2A squared minus A minus 6. These are going to become A's. So we now have a 2A plus a -3A. And remember, they replace the middle term of our trinomial. So we are going to rewrite our trinomial with the plus 2a plus negative 3a, replacing the minus a. And then we have that minus 3 at the end. I'm going to make that plus a negative 3 right away. We have to factor by grouping now. So many things to remember. Make our groups. What's the GCF of the first group? 2a. The resulting factor? A plus 1. That's the first group. Second group, negative 3. Resulting factor, a plus 1. Good news, the parenthesis factors match. So our factored name for this trinomial is? But don't forget about this guy over here, remember him? 2, what was it? No, I think I have it wrong. 3a to the 4th. Whew, I'm getting dizzy up here. 3a to the 4th. A plus 1. Oh, by the way, can that one be factored in anymore? A plus 1?
Yeah.
Okay. How about 2a minus 3?
Yeah.
So, factored completely. Okay. Last one. Does it have a GCF? What is it?
X.
Just X? XY. So there's 5 factors of X here, 1 factor of X there, can only take out 1 X then. 1 factor of Y, 5 factors of Y. Oh, can only take out 1 Y then. XY is the GCF. So what's the resulting factor? X to the 4th minus Y to the 4th. Oh, this is starting to look like that one we did at the beginning of class. This is the GCF. This is the difference of squares, is it not? So what's its factored name? Next question, can either of these be factored again?
Yes.
Which one? Both of them?
All
The subtraction one. This one can't, can it? It's got addition. Arrow it down, it can't be done. Addition says, no, there's not a special product for the sum of perfect squares. This is the one that we should be able to factor again. What are its factors? X plus Y, X minus Y. Can either of those be factored? So this one for sure can't be because it's got addition, right? How about this one? Is X a perfect square or Y a perfect square? No, so they're ready to come down. We are ready to write our answer. XY times X plus Y times X minus Y
Good.
times X squared plus Y squared. Amen. Order does not matter. Typically the monomial GCF is out front. After that, it does not matter which of the factors gets to be next, but because it's multiplication, right? Okay, so this is exactly what you're doing in your homework. Make sure you make note that only 2 are not factorable at all. 55 and 56 are multiple choice. You will not get your paper stamp tomorrow with just a multiple choice answer and no support for it. You I already forewarned you that in those first group of evens problems, none of them will have anything less than 3 factors. Some may even have 4. Do not quit until it is completely factored. 2 factors will never be the case in the problems I assign to you.